Hello everyone, welcome back to the sessions on the advanced communication. This is the unit 1 microwave devices. In this particular unit, this is the session 3. The topics which we are going to cover in this particular session are the different modes in the waveguides. That is the contents, mode of operation. Modes of propagation in the waveguide. That is, waveguide propagation modes depends on the operating wavelength and polarization and the shape and the size of the guide here. That is, how the particular wave, what is the wavelength of the particular signal? What is the wavelength of the particular signal and how it is polarized? It is the electrically polarized, the magnetically polarized, TE wave or the TM wave, and also the shape and the size of the waveguide here. All these factors decides the modes of the waveguide here. Now each mode is characterized by the cutoff frequency, and below that cutoff frequency there is no transmission here. Therefore the mode cannot exist in the guide. Therefore to transmit the signal should be the above the cutoff frequency in any mode, either the TE mode or the TM mode here. The modes in the waveguides can be classified as the transverse electromagnetic wave, that is the TEM mode here. TEM mode, neither electric nor the magnetic field in the direction of the propagation here. Now both are not in the direction, but the direction of the propagation, TE electric wave and the magnetic wave, all the magnetic field and the electric field and the propagation direction, all the three are perpendicular to each other here in the transverse electric mode. And in the transverse electric mode here, no electric field in the direction of propagation, that is electric field is perpendicular to the direction of propagation and the magnetic field is along the direction of the propagation. Magnetic field is along the direction of the propagation, and that is called as the transverse electric mode, TE mode. Electric field is perpendicular and magnetic field is along the direction here. But in case of the transverse electromagnetic mode, what is happening there? In case of the transverse electromagnetic mode, the particular electric field, magnetic field and the propagation direction all are perpendicular. But here it is electric field is perpendicular, but the magnetic field is along the movement here, along the direction here. Next, that is the transverse magnetic mode here. No magnetic field in the direction of the propagation. These are sometimes called as the E modes because there is only an electric field along the direction of the propagation. That is, only electric field will be along the direction of the propagation and no magnetic field in the direction of the propagation there. Magnetic field is not there. It is perpendicular to the direction of the propagation here. Now the hybrid modes. What do you mean by the hybrid modes? That is the non-zero electric and magnetic fields in the direction of the propagation. That is the non-zero electric and magnetic field. Both are there in the direction of the propagation. That is called as the hybrid mode here. Now if you observe the diagram, so these red color waves represent the electric field and these blue color waves represent the magnetic field here. And the TEM mode means what here? Both the red color, that is the electric waves, electric field, magnetic field, and this is the direction of the propagation here. All are perpendicular to each other. If you observe here, electric field in the direction of the propagation and the magnetic field, all the three are perpendicular to each other here. Therefore, that is called as the TEM mode here. Both electric and magnetic field are perpendicular to each other. Here both electric and magnetic field is used at a time. Same time both are used here. Now the modes of the operation, that is the transverse electromagnetic wave here. TEM mode means both, all the three are perpendicular to each other here. Again the TE mode means what? Transverse electric mode. Electric field is perpendicular to the direction of the wave propagation. And TM mode means transverse magnetic mode, that is magnetic field is perpendicular to the direction of the wave propagation. Now these are the different modes here, and in the waveguides usually they will use the TE mode or the TM mode, either the transverse electric mode or the transverse magnetic mode, but they cannot make use of the TEM mode in the particular waveguides because the short circuiting will take place there. Therefore, they are using either the TE or the TEM mode. But in case of the transmission lines, they can go for the either TEM mode also here. These are the some of the modes which we are using the waveguides. Thank you for watching. Thank you.